Welcome, everyone. Thank you for joining us for our webinar Wednesday series. My name is Shabri Datta, and I am the marketing specialist at SNIC Solutions. SNIC is a smart expert partner of Siemens in North America and Asia, specializing in technology and consulting for the manufacturing industry. Today, we are presenting Making Sense of MES and MOM. Please post your questions in the chat window, and we will take them up before the end of the session. Our presenter is Nikhil Joshi, CEO and founder of SNIC Solutions, who comes with 15 plus years of experience in implementing technology and has a background in industrial and systems engineering. Over to you, Nikhil.
Thank you, Shabri, and welcome everybody for this webinar. Our agenda today, in making sense of these terms used as MES and MOM, we will go through ISA 95 standards, which form the foundation of these terminologies. We'll understand what is manufacturing execution systems, what is manufacturing operations management, what you will see out in the market as you do your own research about MES and MOM. And finally, we will very quickly touch base on whether you need MES or MOM technology for your business. We'll end with some Q&As, and let's get started. So ISA 95 is a standard from International Society of Automation Standards that has put definitions that are related to manufacturing execution systems and MOM. Let us understand as to where MES and MOM fit into the story of ISA 95 standards. International Society of Automation Standards is the most prestigious and recognized body in the automation ecosystem. And to put it simply, most of our manufacturing facilities have already machines that are part of our system, and ISA 95 defines this as level 0, and they being actual physical processes. It could be simple assembly operations, it could be manufacturing machine CNC operations or bottling lines. Whether you're a batch manufacturer, whether you're a discrete manufacturer, a continuous processor, a mix of all, everything is covered. Basically, everything that is on the shop floor is defined as the actual physical processes. We then move on to level 1, which is where you bring in your sensors, your PLCs. And level 1, as per ISA 95 standards, defines all the activities involved in sensing and manipulating the physical process. So if I need to tell the machine stop or start, the sensors are what actually sense and manipulate this information. Going further to level 2 is defining the activities of monitoring and controlling the physical process, which is more known as SCADA. And this is where you actually visually can control, monitor, see what's happening to your machines, your systems, and also take actions like immediate shutdowns, alerts. All these are covered basically at level 2. At level 3 is where MES and MOM come into picture. And essentially, level 3 is defined as the activities of workflow to produce the desired end products. So manufacturing operations management is considered sort of as a bridge between the SCADA, PLC, and machines that you see below, and the level 4 systems, which are the enterprise resource planning systems that define business related activities, whether it is sales, finance, forecasting, high-level planning, or just in modern day world, just apps which are front-ending to the business users. And if you see, the level 3 is sort of a bridge between 4 and level 0, 1, and 2. So if we come to the question, what is MES and MOM, taking the same structure of level 2, 3, and 4, is that we have the automation systems in our manufacturing plant. And to tell you basically a bit of a history, manufacturing execution system as a word has been around for more than 20, 30 years. And it was essentially used for any legacy systems that were built on top of these automation systems to either do some sort of production management, run some sort of manufacturing intelligence. It was all in bits and pieces. The word manufacturing operations management became very popular after ISA 95 standards coined level 3 as manufacturing operations management. And this is one of the reasons that manufacturing operations management is fairly new. It's being used from the last 10, 15 years or so, but the predecessor being primarily known as MES. And in the modern day world, MOM and MES are used, almost in conjunction together, representing the same. But let's typically understand the components of manufacturing operations management here. If you see, manufacturing operations management, unlike before, is becoming much more holistic, where it is becoming responsible for the entire execution and intelligence of the manufacturing ecosystem, particularly the production floor. So whether we talk about quality, production scheduling, production management in terms of tracking, traceability, compliance, or just manufacturing intelligence areas like overall equipment effectiveness, etc. All these are independent modules and subjects in themselves, but they all holistically put together define manufacturing operations management. Let's understand going further what is really MES in this entire ecosystem. So if we take a digital factory flow, some of the terminologies you may already know, but just for everybody's understanding, most manufacturers, all of us have ERP systems. They could either be home built, homegrown, or we would have some of the industry standards ERPs of the world. And essentially, ERP was born in the finance world, and all the other modules that are built around within the ERP are made to support the primary key function, which is accounting and finance. And then we have PLM systems known as product lifecycle management, which typically make our product design better, ensure that our engineering bill of materials, or in terms of process industries, recipes, etc., are managed basically in one system. This is where we come to the third area, which is manufacturing execution systems, which has everything to do with production, quality, inventory, and the synchronization of all these functions. You then have the shop floor, which is actually producing the goods, the finished goods. And then you have advanced planning and scheduling, which is also part of manufacturing execution system, but needs to be looked at separately as separate modules, primarily because of the nature of production scheduling. You could have one facility could manufacturing, let's say, shoes, and if you have a similar facility in another part of the world with exactly the same machines, there could be a possibility that the way schedulers would sequence the constraints they would take into account would be different. Let's understand typically how a digital factory would flow. So you have customers giving the requirements, And if it's a standard product, you don't need to do any design, it's already ready. But once, if there are custom requirements in terms of a make to order or engineer to order, you may have to custom design. And this is where you use your product lifecycle management system. And this produces a component list, which is your bill of materials, what goes into a bicycle, for example. It's the wheels, it's the seat, it's the frame. All these components are basically the bill of materials, which are maintained as a master, ideally in a digital factory in the PLM. You're also having the bill of process, which is the process definition. Do we first, machine the component? Do we then paint the component? Do we then pack it, or do we first assemble it? These sequence of steps, whether they are routings in terms of make to order industry, or recipes or processes in a batch manufacturing environment, the bill of processes are sent to a manufacturing execution system. If you see in parallel, ERP and the purchase officers are taking care of all the purchases that need to be done from external vendors. And this entire purchase and the production orders are a list that are sent from an ERP to an MES system. Once the MES basically has the bill of process and the production order lists, it further maintains detailed activities of tasks, detailed recipes, detailed steps for a high level bill of process, which is used for shop floor execution. And what is happening in parallel is that the ERP is also checking for component availability and making sure that when a production order list is given to the MES, it's also giving the information of when the components are going to be available for starting production. So as MES gets this information, a production snapshot is sent to a production scheduling system where you could take the factory constraints, go ahead and make sure that you have the best sequence to run the factory floor or the plant very effectively. And the scheduled operations with a specific start date and an end date is what is given back to the manufacturing execution system, which in turn releases part programs, instructions, the production orders that have to be executed on the shop floor. The shop floor in turn takes either data from sensors, from manual entries, from barcodes, and it gives the production feedback, which goes back into an MES system. And then MES also gives back production performance to understand planned versus actuals, etc. And finally, for ERP to do its accounting and bookkeeping of inventory, stocks, further ERP to do finance, costing, pricing, etc. And this in turn is a flow that keeps repeating in itself. And this is, in a nutshell, from a manufacturing operations management point of view, a high level digital factory flow. And finally, MES is also giving engineering feedback to PLM in terms of whether engineering drawings need to be improvised, whether designs need to be improvised. Did we find anything in terms of quality that could be improved? These are some of the feedback that MES basically gives to a PLM or a design software system. So what will you see in the market as you go and do your research? You will see that there are SCADA softwares that are available, and they are also known as DCS systems. So think of your machines, or if you're having a process plant, a beer plant, a food manufacturing, the machines typically already have PLCs, sensors built in. But the modern day SCADA systems are coming up with something known as open platform communication, or known as OPC. This allows any machine following OPC protocols to connect to a modern day software system. The traditional SCADA software had limited capabilities in order to connect, and you would typically have to go forward with the systems that were given by the machine manufacturer in order to uh, uh, see what kind of data you could collect. So if the machine manufacturer had, let's say, pressure and temperature built in its machine or in its PLCs, you were okay to get pressure and temperature. But let us say a third parameter like a breakdown status, if that was not built in, then it would be very difficult to capture that data. But open platform communication and OPC servers make this easy to talk to modern day software interfaces. Now, SCADA softwares have L1 and L2 capabilities, and L1 and L2 are nothing but level 1 and level 2 capabilities as per ISA 95 standards. And many SCADA softwares are providing today MES modules, but with limited L3 capabilities as add-ons on top of their SCADA systems. So this is one kind of software that you will see in the market. The second is manufacturing intelligence or Internet of Things. There has been a very big buzzword, not only in the manufacturing industry, but in whether you talk about smart cities or talk about windmills or power generation or mining companies, where uh, instead of MES or MOM, the word that is very popular is industrial Internet of Things, known as IIoT or just as IoT. Uh, what these softwares are capable of doing is that they have the same level 1 and level 2 capability of having sensors that will talk to machines, etc. But the requirements of manufacturing intelligence is just to give analytics. It could be just a simple OEE report, which is overall equipment effectiveness, or it could just be, I would like to control and see what are my planned versus actuals on the shop floor. I just would like to see the analytics, but I'm not going to do anything more than that. So these also basically have MES modules as add-ons, but again, they would be limited in terms of the L3 capabilities. And then the third area where what you would see is the actual manufacturing execution systems, which are enterprise level or enterprise grade MES systems. What is so different about these MES systems versus the first two? And in simple layman terms, the first two is what I call as bottom up MES. They grew basically in manufacturing plants from the bottom up. They started to say, hey, I need some data from the machine, and you go and build on top of that. The third MES execution system actually is a top down MES, which comes more from the world of ERP, that when you implemented ERP, primarily because ERP systems were meant to serve finance functions, ERPs had limited manufacturing execution capabilities. Although today many ERP companies are providing manufacturing execution modules, but again, as a business model, if the ERP company's primary business model is to serve those core components of finance, sales, or the business functions, there's always a debate among consultants, among professionals, among industry practitioners, whether would they do justice to manufacturing execution. So what you see today in the market are independent software companies providing a suite of enterprise grade manufacturing execution system, which would have modules related to tracking, related to quality, related to scheduling, and related to intelligence. But along with this, they wrap security uh, uh, so that plants can be prevented with any sort of hacks. And if you choose to go to cloud-based versus on-premise systems, all the security features are graded, and hence they are known as enterprise-grade manufacturing execution systems. Now, these manufacturing systems primarily have come as top-down MES. So, as from a capability standpoint, they are meant to serve L3 level or level 3 capabilities of ISA 95 standards, and they will not have uh, SCADA kind of capabilities because that is covered in level 1, level 2. But certainly, they would have manufacturing intelligence or Internet of Things or IoT capabilities built into their intelligence modules. So these are the things that you would see out there in the market. And finally, to come to our last section of this short webinar is that do you need MES or MOM? I'd like to take this question more from the perspective of look at your manufacturing plant, whether you're a batch manufacturer, whether you have a lot of manual operations, whether you are an engineer to order or a make to order company, or whether you're just a make to stock company, any kind of situation, uh, to understand if we need MES or MOM is to look at the symptoms and what are the potential business impacts. From the many case studies and the implementations that we and many other companies and our partner company, who we are channel partners to, that is Siemens, have done, we have collated some of the symptoms that we time and again see uh, 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 in the vicinity of MES and MOM. So the biggest one has been non-conformances, and whether if you have increased non-conformances, it's a very big issue from a customer standpoint. And reducing the non-conformances has typically seen an increase in profitability because it reduces your overheads, both in terms of regulatory overheads, in terms of your audit overheads, as well as in terms of your compliances. The second symptom is supply chain responsiveness. If a customer calls you and say, "Hey, I know you were to deliver to me 2 weeks from now, but I need this tomorrow. Can you do it?" Today, sales professionals and supply chain teams take a decision based on maybe average lead times or judgment. But what if you could quickly respond with accurate data that has a direct impact on on-time delivery? Asset utilization has been one of the symptoms where companies go and do a lot of capital investments, thinking that there would be demand, but in terms of uh, 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 when demand basically is varying and it's fluctuating, companies are focusing more on asset utilization before they go and open up an entirely new plant or invest in new machines. And looking at uh, uh, getting more from your production shop floor, from more from your people, from your machines, comes under the category of asset and resource utilization, and it has a direct impact on sales revenue. Cost of poor quality in terms of quality management, whether it's inline inspection, offline inspection, doing quality assurances, FMEA, BFMEA, PFMEA. These are covered very well by lean manufacturing initiatives, operational excellence initiatives, continuous improvement drive, but it just involves too much paper, and it just makes everything slow. And cost of poor quality is where we have seen that removing paper increases uh, the coordination and ensures basically that quality is managed better. reducing the overall lead time for quality activities in your factory or your plant, which entirely has a net impact on an improved cash flow. This is my favorite. Multiple truths due to lack of visibility. When we visit multiple plants, even if they have invested millions of dollars in an enterprise system or have legacy MES systems, we often see them using spreadsheets, and everybody has their own spreadsheet. And these spreadsheets don't talk to each other, which brings in lack of visibility. But more importantly, it creates multiple truths. And having a singular truth leads to increase in an overall productivity. And finally, one of the biggest system, which is a no-brainer for an MES or a MOM, is firefighting culture. If you are reacting uh, to what is happening on the shop floor, then chances are that you are slow and way less responsive. And this is where the direct business impact MES and MOM can provide is increase in speed, which is very strategic in nature. So many new companies try to implement MES and MOM right from day one because they want it as a strategic advantage. But if you have already existing facilities, then you could see this helping you increase in speed and come to the level of your competitors and have that competitive advantage. With this, I hope the session has been valuable to you in terms of making sense of MES and MOM. Over to you, Shabri, back again to see if we have any questions.
Nikhil, we don't have any questions right now.
All right.
From the
Thank
audience.
you so much. Thank you so much, everybody. Back to you, Shabri.
Thank you, Nikhil, and thank you everyone for attending the webinar. We will send you a copy of the recorded webinar by tomorrow. Please feel free to write to us on sales@snicsolutions.com if you have any other questions. And thank you for attending.